Oh my God. Why is this happening now? You're not that funny, Tyler. I'm not that funny. Okay, how do you handle high volume of data without it blowing up in your face? My guest today is a big fan of Pinot. Not the alcoholic beverage, but the Apache Software Foundation, well, open source software. He's gonna teach me all about how Pinot works with Amazon Kinesis and Amazon Bedrock for some anomaly detections with generative AI shenanigans. Let's go meet Tyler. Tyler?
Darko.
Welcome, welcome, welcome. Tell them, who are you, what do you do, and tabs or spaces?
Tabs or spaces. So first, my name's Tyler Denton. I'm a solutions engineer at StarTree. And tabs or spaces, I am definitely a spaces guy.
Of course.
Hands down spaces.
Always expand your tabs into spaces, my friends. Now, you came here to show me something really cool with Apache Pinot. Tell me, first of all, what is Apache Pinot?
So Apache Pinot is an open source real-time analytics database
Sure.
that exists for when you have high volumes, high velocity data, and you need to get insights very quickly, like immediately.
That fast?
That fast.
How fast?
Well, to me, fast is milliseconds. So from the time data is generated to when it's queryable, we're talking less than a second. And we're talking in the milliseconds range for how fast your queries are going to run.
Amazing. Now, I know you prepared this demo, and we're going to have a look at this diagram because we have Python, Bedrock, Kinesis, Pinot, IoT devices. Let's go and have a look. This is the architecture diagram. Tell me what this is.
Yeah, so it's pretty simple. We've got a control panel for managing these rooftop units here, these air conditioners.
Air conditioning, okay. I was like, what is a rooftop unit? Air conditioning, okay.
And we picked rooftop units because they're simple to understand. Everybody's got an air conditioner.
Sure.
Those generate data that go through MQTT
Okay.
into Amazon Kinesis.
MQTT, folks, mosquito. It's just what IoT devices like to use to send data. Okay, well, to transmit data too. Amazon Kinesis, it's our service that basically provides you ability to stream high volumes of data that can be consumed by something else. A Lambda function, an EC2 instance, anything that's a consumer, including Pinot. What is Pinot doing here?
So Pinot is that first-class consumer from
Okay,
Kinesis.
okay.
And so we are consuming that data from Kinesis
Okay.
without any kind of batching. No micro-batching, nothing. It just brings that data in,
Okay.
makes it queryable immediately. So as soon as you write that data from the bridge into Kinesis, we are pulling that data off the wire and making it queryable by our control panel. So while we're talking about air conditioners and rooftop units and IoT devices here, that's not the only thing that Pinot is good for. Companies like Uber, Walmart, LinkedIn, they're running Pinot, and you can run Pinot too, using EC2, EKS, or you can use StarTree, the managed service for Pinot, that provides multiple enterprise features on top of the open source Pinot.
So what's the tech manual thing? What is happening here?
Yeah, so you don't know how to work on an air conditioner, right? I don't know how to work on an air conditioner, but I know how to read a manual.
Okay.
And so what we do is we take that manual, we put it through a vector extraction process using Amazon Bedrock.
Amazon Bedrock mentioned. So Amazon Bedrock is the easiest way to build and scale applications powered by generative AI. It is a place where you can invoke, host, and work with generative AI models, as well as knowledge bases, RAG, agents, and a whole lot more. Bye.
We write that data into S3,
Okay.
which is then consumed into Pinot.
Pinot, okay.
So Pinot becomes the vector store for this data,
Okay, love
so
it.
that we can then perform anomaly detection.
And is that a script? Is that an EC2 instance? What is anomaly detection?
Yeah, so this is the script. You can run it wherever you want,
Okay.
but it's taking a bunch of queries
Okay.
that do anomaly detection, rules violations, things like that,
Sure.
and creates those alerts. We use the alerts with the data from the vector store to generate recommendations for how to resolve problems or anomalies with our air conditioners.
Now, it takes the tech manuals, so it gives people instructions how to do stuff, right?
Exactly, yep. So instead of going and searching through the tech manual to find this specific problem with this specific solution and how to do it, it takes the knowledge from those tech manuals, stores it into Pinot as knowledge,
Yeah.
then takes the information about that, along with the anomaly that's detected, sends it to Claude in Bedrock, generates the recommendations on how to resolve the problem, and presents it back to the user.
I love it. Since this part we're all just going to be emulating, this doesn't really exist, let's start with Kinesis. Let's actually have a look how Kinesis connects with Pinot, and you can show it to me on the actual demo. So let's have
Absolutely.
Is this Pinot?
This is Pinot. So this
Okay.
is the open source Pinot UI.
Okay.
What we're looking at here is the definition of a real-time table.
Okay.
So Apache Pinot has two concepts of tables. Technically, there's three. A real-time table, an offline table, and then a hybrid table that combines the two.
Okay.
What we've got here to stream this data in from Kinesis into Pinot is a real-time table. What I find so cool about this is that all these other databases out there are doing micro-batching. They're grabbing like, we're going to grab 100 records and bring it in, and then index it and write it, and then we'll go and get more data and we'll bring it in. Pinot doesn't do that.
Okay.
We have a first-class consumer that is streaming that data in, writing it into what's called our consuming segments, and making that data available for query immediately.
I want you, so like the consumer, the Pinot is the consumer itself, right?
Pinot is the consumer itself, so no intermediary, no having to create any kind of special integration to write it. You just code this up, and off it goes.
And again, for the folks out there, I assume Pinot can work with other things besides just Kinesis?
Oh yeah, particularly in our real-time tables, we can bring data in from Kinesis, Kafka, any of those different streaming platforms. We're able to bring that data in.
Nice. No, so okay, I see a real-time table. You mentioned offline table. How do you create this table? Is there something you need to do? Is it automatically doing it from what data it receives from Kinesis?
So we define the table.
Okay. Show it to me.
First thing, we're going to create a schema.
Okay.
And so the schema has a couple different data fields in it. So we've got our dimensions, metrics, and then our date time fields.
Okay.
So you specify this, tell it what it looks like, how it works. From there, we define the table, and the table gives us the ability to specify the partitioning scheme, the types of indexes we're going to build, and particularly with StarTree is creating the StarTree index, which is the power of StarTree.
So that's something I need to learn. So I've heard of the StarTree index, and that's kind of the whole powerful part of this. What is the StarTree index, and why should I care about that?
Yeah. So imagine you need to build a materialized view.
Okay. What's a materialized view?
Oh, okay.
I'm asking for them, of course.
Because we know you know.
Yeah, I know, but right? just for them. Yeah.
So a materialized view is where you're going to take the results of a query or some type of thing like that, pre-process it, and store it in its own table.
Oh, okay. So for faster access, right? Or for like just being able to access that data faster, you do have to do computation all the time?
Absolutely. So you do the computation once. The problem is with those is that they run on a timer.
Ah, okay. So they're like scheduled and all. Okay.
They're scheduled and they recreate every 5 minutes, let's say.
Okay.
We're bringing data in the millisecond range. Waiting 5 minutes to generate a materialized view defeats the whole purpose.
Exactly. Yeah.
And so we do this in real time. We're going to specify the dimension split order, which is what gives you your filter criteria in your query.
Okay.
And then we're going to say what we want to project. So mins, maxes, HLL counts, all sorts of different things that we want to do. We can store those in our materialized view, the StarTree index, and then issue those queries that use this and not have to go to the raw data and do these aggregations.
And it's also kind of happening in real time. It's also like
absolutely in real time.
So and what I see here is machine ID. That's I guess the machine in the back.
We're gonna get to those machines.
The rooftop unit, and it's kind of getting all of this data and it's setting up this. Love it. Okay, nice. And it is. I assume it's slightly less fast than the actual. Is it also
absolutely
millisecond?
not?
Yeah. Oh, okay.
No.
Okay.
No. So it is calculated in memory as we're ingesting that data. And so remember, we're talking about those consuming segments and then the segments for the real-time table.
Yeah.
The whole point of this is that creating this and generating this doesn't slow down the ingestion.
That's amazing. Okay, folks, we're going to leave a link in the description below under the like button so you can go check out a little bit more science behind the StarTree algorithm. So awesome. So we have a table created, we have a schema, and now this thing will just automatically accept this data. Can we see a little sample data here? How can you query or something?
Yeah.
So I want to see actually how that looks like.
So let's come in. We'll let's go into our query console. We'll go to our table that we've defined here. Go ahead and query it, and now we've got data coming in.
That's it. So it's very much SQL, right? Like it's
you write SQL queries all you want.
Oh, awesome. Is it SQL or SQL?
Well, I'm going to call it SQL. I understand it's wrong,
right?
But it's right.
Actually, you're actually. History lesson for another time, but he is correct actually. So okay, awesome. So it's just SQL database, and you can query this, and you can query it from anywhere else. You don't have to query it within Pinot.
Yeah, we've got a full API that allows you to integrate. We've got JDBC drivers, all sorts of things that you can use there.
I love this. Okay, now I want to see something else. I know this is great. We got the data in, right? We get it from Kinesis. The data is in Pinot now. I want to understand how you do something with vector stores here.
Okay.
In the diagram, you showed me a little bit about the vector store. So let's go talk about that for a second, and I want to see what you do there. So let's go back here and look at vector extraction.
Yeah. So you ever worked on a rooftop unit?
I have not.
So you don't know how to fix one?
I don't know.
Okay. So what I can do is I can teach you. I can
Okay.
teach you how to work on one.
Okay.
Because I've gone and I grabbed a tech manual,
Okay.
a troubleshooting guide, and I broke it up into a whole bunch of pieces
Okay.
and used Titan
Okay.
to create some vector embeddings
Okay.
and put those in Pinot.
Let's see that in action.
Absolutely.
How do you create these vector embeddings?
Yeah. So here's where we're storing them, but to
Okay.
get to them,
Okay.
first, you said you didn't know how to use how to work on an air conditioner, right?
I did not know.
So the first thing you're going to do is you're going to go get a tech manual.
Okay.
And so hopefully, right? You're
Hopefully,
not just
yeah.
going to go take your air conditioner apart and try to figure it out.
I did try that once. Okay.
So we've got a tech manual.
Okay.
And I've gone ahead and used this to go and using LangChain and a couple different other tools, go and take that PDF of this tech manual,
Okay.
strip all the stop words and things like that out of it, extracted that text from the PDF,
Okay.
turned it into chunks, and sent it to Bedrock,
Okay.
where we're going to use this Titan embedding,
Yeah, that,
which we've talked about.
exactly. Yeah, okay.
And so from there, we take those vectors
Okay.
along with the original text,
I see it there.
and we're going to write that into JSON files.
Okay, okay,
Those JSON files we then upload to S3.
okay.
And-
Well, before you go, so tell me a little bit more, and you know, I know what embedding is, but what is embedding in this case? Because, right, you're using a large language model here, or an embedding model, to convert your PDFs, or convert the text from PDF into vectors. What is that? Why are we doing this?
Yeah. So it's really hard to use a SQL engine or something like that, like an inverted index, which most people would use,
Yep.
to take an alert or an anomaly
Okay.
and say, all right, go find me all the text in this tech manual that matches that. Because it doesn't necessarily match that. It doesn't mean anything. And so what we use is we use vectors to do things like cosine similarity to find words or language that means the same thing. And that's the whole point of the embeddings model.
Exactly, exactly.
So we can then return the original text that is close in meaning to the data that we're querying against.
Okay, okay.
And then use that as augmentation to our generation later on, once we've got anomalies, to come up with recommendations for how you can go fix your air conditioner without breaking it.
Okay.
Even worse.
And your JSON here basically has the original text, the vector data, and a random ID, right?
Yeah, a random ID.
Love it, love it. Okay,
What's
so
something cool here that we could add is if we had other metadata, if we had other things that we were going to filter on.
Yeah.
Like right now I'm only ripping apart one tech manual. But let's say we had 1,000 tech manuals. I could include in this JSON the manual it came from, let's say, or the page it came from.
yeah, exactly. Yeah.
And then with Pinot, we can not just do the similarity searching, but we can also include metadata filtering, which is something very unique to Pinot.
Okay, oh, interesting. So show me, you mentioned this sitting at an offline table. How does this get into Pinot?
Yeah, so I already dumped it into S3.
Okay, so it's in an S3 bucket. Okay.
Yep, it's in an S3 bucket. And here, much like the first-class citizen for bringing in stuff from Kinesis,
Okay.
we have a first-class citizen for bringing data in from S3.
I love that. Okay, okay.
We've specified that it's JSON data.
Okay.
We've configured our IAM role. We set things up. Here's our role definition.
Yeah.
And we say go. And it's going to go and it's going to get all that data. It's going to bring it in.
I see it has a schedules here. It's a cron schedule. Shout outs to cron. It has every 20 minutes. Is that the correct? I don't know how.
I got to put them in the decoder every time I write them. So
Tell me in the comments. Is this every 20 minutes? I don't know. It's impossible to tell. So it runs on schedule, so this is not real time, and it doesn't have to be real time.
no,
right?
it's
Yeah.
specifically an offline table.
Exactly, exactly. So now, your code that you showed me a second ago, is that run automatically somehow here, or is that manual execution? What?
It's a manual thing, because
Okay.
how often are you going to go get tech manuals?
True.
I mean, you could automate it, build a pipeline, do all that, and get really complicated, or you could write it in Python and be simple and just do it like I did.
Exactly. KISS, right? we all know what KISS means. So, okay, awesome. So you store it in S3. Pinot has direct integration with S3. It pulls this thing every whatever the cron says.
Let's
here.
say 20 minutes.
Let's say 20 minutes. Yeah, why not? Or 20 days. We don't know. Okay, and it ingests it into this offline table. How do you query? And you can just query this like normal like with a SQL query, but...
Before we can query it, we got to index it.
Oh, okay, okay.
And so we actually specify here this vector index. And that is the unique part of this, of Pinot here, is that we're actually saying what kind of vector store we want to use. So we're storing this to support cosine similarity queries. And so that's really the magic in this section here.
So while Pinot is not a vector database per se, it does support the vector index type.
Absolutely. And so what you can do in a vector database, you can do in Pinot. We can also do things like metadata filtering and inverted index querying and things like that.
So just tell me why is cosine a vector distance function important? Why is that a big deal? You mentioned that like as an important element to this.
We'd have to get into like machine learning and a deeper concepts.
We'll have a bunch of links in the description so you can check it out. But yes, it is an important element of this whole thing. But I love it. Okay, awesome. Now we have this ready, and we are going to be using this as part of our anomaly detection. Is that
Absolutely.
correct? Okay, so let's go ahead and see whether this anomaly detection exists here, and they're going to show me how that all works. So the anomaly detection thing here.
Here's your cron again.
Okay, another cron. Yeah, look at that. Okay, so anomaly detection actually picking up that. Well, actually, tell me what it does.
Yeah. So I've written an anomaly detection script.
Right.
That we've got some queries in there. We'll go through the queries. We may even write one.
Okay.
That queries Pinot.
Okay.
On a schedule.
Okay. Look at that.
A schedule that I control.
There you go.
That schedule runs depending on any anomalies that are detected. It's going to then take the anomaly that's detected, run it through that same embeddings logic as we did for our tech manuals.
Okay.
Then we can run a cosine similarity query, pull back the information from the tech manual to include that information along with the information from the alert, the anomaly, feed it into Bedrock here for our LLM to generate the recommendations for how you can go fix your air conditioner.
I would love to see that code. Come on, let's have a look. Anomaly detection.
Yeah, so anomaly detection is pretty simple in Apache Pinot. Okay. So first, we've got to come up with some queries that can do anomaly detection.
Okay. So what's an anomaly here? Are we talking, like high temperatures or what?
Sure. Yeah. So remember that we built a StarTree index on max temperature, min temperature, max pressure, min pressure, blah, blah, blah. And so very easily, I can then start querying for what's the max temperature and set a limit. Very simple, right?
Okay.
These are the simplest kinds of anomalies that you would want. You know, gas gauge on your car is going below a quarter tank.
Right.
Should probably alert you to tell you to go get your gas tank filled. Same thing with these rooftop units.
Okay, so in this case, this is a bunch of, so this is a queries.json file that contains a bunch of
rules.
Rules. Oh, so there's rules. Okay, so name, narrative, narrative. It's supposed to be description, but sure, narrative, I guess. A narrative and a SQL statement here, right?
Yep, and we got some parameters. And so this isn't specific to Pinot at all.
Okay.
This is how I designed or decided to write a rules engine using
look at you.
Apache Pinot.
Okay.
And so here we've got these parameters, and so my anomaly detection script is going to iterate through these parameters depending on what you specify, and run a bunch of queries for them. Okay. And so these are simple rules-based engines.
Okay. So if I would like to write another rule here, so what do I need to do, right? Again, this is a typical, so I see again, a name of a rule, a description, a narrative, a SQL statement, and a parameter. So how can I know which which things can I pull from, like, for example, the fan speed or the temperature? How do I know, where do I get that information from? Is that what's contained in the what's the word, the real time? You're close. Okay, in the real time, not in the offline database, the other one, the
schema.
The schema, oh, it's in the schema, okay.
Right, so if we come back to our real-time table,
I see it,
and we look at the schema, here we've defined temperature, we've defined compressors, blah, 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 all of these different fields that we know we're going to be bringing in via MQTT from these devices. And so you can then start writing queries on top of it.
Oh, okay. So are you using specifically the StarTree index here, or that's just normal queries? Like in this case, because I remember we did the StarTree index with the max temperature or whatever. Are we running anomaly detection on that, or just normal data we have in the streaming table?
So some of the queries we're writing are using the StarTree index.
Okay.
But then, like, we can get super creative and write linear regression queries that are going to go and generate standard deviation and create an R-squared value and find values that are outside of that, right? You can do all of this in StarTree. Here's, super simple use cases to, all right, let's get into some real data science for how to write these things. Yeah, it keeps going and going.
That is a very complex. By the way, we're going to keep all this code in the description. There's going to be a repo for you to actually go ahead and check out this code, so you don't have to screenshot whatever.
Yeah, it goes on and on and on.
Okay, awesome. So, what runs these queries?
Yeah. So here in Docker,
Okay.
where I'm running everything, I built this service called Anomaly Service.
Okay.
And it just runs. So I want you to restart.
Okay.
And I want you to run every 60 seconds.
Okay, back to cron jobs. Okay.
Yeah, it's a cron job.
Back to
only
cron jobs.
only we wrote it in a way that I don't have to break out a cron calculator.
Shout out to cron. Okay. Okay. And then,
So what we can do is we can make a new one,
okay, let's
a
do
new query.
Okay.
And so here I started writing this.
Can you zoom in on this one slightly so we can see it a
Yeah.
little better? There we go.
Maybe.
Okay, nice. Good. Okay.
So we've got common table expressions.
Sure. Okay.
What I'm doing is I'm grabbing that max temperature,
And that's coming from the StarTree index?
StarTree index,
Okay.
min temperature,
Okay.
coming from the StarTree index,
Okay, love it.
and grabbing the diff of those temperatures.
Okay.
And so here is where we're going to put our parameters for when we're running.
Okay.
And then all we got to do is select if a value is greater than that, then there's an anomaly
Okay.
based on the parameters that we put in.
So the anomaly is actually being detected within the SQL query, not the Python script, right?
Absolutely.
Okay,
We are
okay.
not using Python to do it. We're using Python to run the queries.
Okay. Awesome.
And so this would say, hey, this violates a rule for your query is greater than, the difference is greater than 30.
Okay.
And so we can run and see no alerts.
No alerts. Okay.
But if we were to drop this down to, let's say, 20,
20. Sure.
right? Oh, man.
Look at that. Beautiful. Seems our fake air conditioning runs pretty good. Look at that. Amazing. What? Look at that.
There we go.
Okay,
It ran.
we have-
So we can
We
take
found the
this.
problem. Okay.
Yeah,
Okay.
there we go. Now it's the difference. There is a difference in max and min
Okay.
temperature. Yay. So we could take that
Okay.
and we could write it into these queries. And so we could say name,
Right, the
narrative.
same thing.
And I picked narrative for a reason.
Why did you pick a narrative?
Because we're using RAG.
Oh, it's a good story. Okay, that's right.
It's not just
Yeah.
a description, it's
Right,
a
right,
narrative
right.
of what's happening.
And that's going to be later on presented to Bedrock when it responds to
Absolutely.
Okay.
So-
Show me that. I want to see that.
Yep. So here in detection,
Okay.
we're going to go and we're going to take these queries and we're going to iterate through those queries.
Okay.
Take the parameters, pop
So
them
it
in
runs.
there,
Okay. It runs.
make all of our queries.
Okay. So it runs those Pinot queries. Like, is there a specific Pinot library for Python to run this, or is this just normal SQL stuff?
So I'm an old school Python guy. There is a library, but I'm using requests.
Request them, sure, of course. I love it. Okay.
Easy. And so I don't have to go and use pip to grab a Pinot library too.
Love it. Okay.
So we go and we create any errors that came in
Okay.
or alerts, however.
Okay.
Then we're going to go and take the narrative from those alerts that were generated.
Okay.
We're going to go through and do a similarity search across that narrative.
And you go to the vector database.
We go to the vector database that we built earlier,
Okay,
or the
okay.
vector index.
So you use where vector similarity. Nice. Okay. Love it.
Yep, and so that's where we get order by the distance.
Okay.
So that's what cosine similarity gives us.
Okay.
And we grab that original text.
Sure. The shorter the distance, the closer it is to meaning or to the
To
similarity.
the similarity.
Okay.
So we're going to grab, a couple of those.
Okay.
Then we're going to go and we're going to say, hey, there was an alert associated with this machine,
Okay.
the RTU.
Okay.
Additional information
Okay.
came from the vector store.
Okay.
Use previous information to generate an alert, and we send it to Bedrock with the invoke model.
So prompt mentioned. I see that we have prompt. Basically, you are forming a prompt here for everything you get back.
Yep.
And for every row you get back. No. Sorry. Yes. You create this and then you use the invoke model from the AWS SDK to send all of this information over to Claude 3.7 Sonnet on Amazon Bedrock.
Yep.
Nice.
The information we get back
Okay.
then looks something like this.
Okay.
We've got an alert.
Oh, nice. So there's an alert outside of per second range. I love it. Alert.
And here is the recommended actions. So now, you can go and inspect the reversing valve. You may want to figure out what a reversing valve is.
Yeah.
Check the refrigerant levels, check for dirty coils. You could do that.
Yeah.
And evaluate the system capacity. And so where this falls, the LLM is saying, based on the information I got from the tech manual, the alert that was generated, and what I know about things in general, because I'm an LLM, this is what I think you need to go do. And now we've pumped that right back into the HMI, the human-machine interface, for the techs to go and work on these rooftop units.
I love this because, again, this whole data, this whole text issue details, recommend actions is generated by Bedrock with the information it got. And now, instead of the tech guessing what to do with this raw information, actually gets out of it. I think that's a very cool use case. Nice. Well, yeah, big fan of this. And then again, you can also modify your script to actually return some other information. Maybe if you want to do a little bit more details on the raw stuff. I love that. But this is really cool. Okay, Tyler, thank you so much, my friend. This was great. Again, I love the fact that you used a bunch of different relatively complicated systems to build something cool and useful. And I love the usage of Gen AI here. Now, folks, I did say a lot of things. It looks complicated, but it's actually not, right? You need data, you need Kinesis, you need Pinot. You can actually host Pinot on StarTree. You need some Bedrock and some technical manuals to make this work. The code is going to be down in the description below, so you can go and check it out yourself. Anything else I failed to mention in the thing?
Yeah, the only thing I would say, Darko, is that we talked a lot about IoT data, rooftop units, air conditioners. But that's not all that we're doing here.
Yeah.
Pinot can work for any high volume, streaming, fast moving data where you need continuous insights. You need those insights fast and you need them fresh. Yeah. And that's really where we fall.
Yeah. Okay. Well, amazing. Tyler, thank you so much. Folks, thank you for joining us. Tyler and I need to go check those inversing and valves and dirty coils, so we'll see you in the next one. Bye. Let's go. It's up here to the rooftop. Just have to go all the way here in the thing. Almost forgot. If you like this video, drop us a like. And if you'd like to see more content like this, subscribe to the AWS Developers YouTube channel. See you in the next one. I have to go now. Bye.